When I was a kid, bird classification was easier. For example, the raptors. This was a group of birds, a biological category. Going back to the days of Linnaeus, these birds were grouped together as related, and they shared features like a hooked beak and sharp talons and the behavior of hunting living organisms. Sure, you could maybe split the order of raptors into separate families, with eagles, hawks, and falcons in one, owls in a second, vultures in a third, and I'm not quite sure what you would do with some other birds like condors, secretary birds, or the caracara. But in any case, these were all raptors, and they were all related. Life was easy back then. The great thing about science, however, can also be a very frustrating thing about science. If one constantly tests your previously held conclusions with new data, with new perspectives, you can point out places where you did not have the fullest understanding of the natural world, and sometimes even places where you were wrong. The problem is, once we have a conclusion that we've grown up with and we accept, we don't like to admit that we're wrong, and we don't like to change our way of looking at the natural world. Ongoing scientific comparisons includes how do we classify birds. We can now compare birds using a far greater list of anatomical features and a far more complete collection of modern birds. But perhaps the most powerful tool is that now we can compare their molecules, their DNA. Now, because there is so much DNA, and some regions of an organism's genome might be better suited to comparisons than others, and because we are continually getting more samples from more species of birds, a DNA comparison done, say, in the 1970s might be superseded by one done in the year 2000, which might then be superseded by another one done in the year 2020, etc. But as we have more and more data in our data sets, we hope that our understanding of bird classification is getting closer to the biological reality of who is most closely related to whom. In our modern understanding, falcons are the least related to these other birds of prey. They are put in their own order, falconiforms, and this order is actually most closely related to parrots and songbirds. While a kestrel would belong to the family Falconidae and the subfamily Falconinae, this other bird, the crested caracara, is also in the family Falconidae in the order Falconiforms, but its subfamily is currently under dispute. Does it belong with the kestrel? Does it belong with the forest falcons? Or does it belong in its own subfamily? The owls are currently classified in their own order, strigiforms, not with any of the other groups of birds of prey. Within that owl order, the barn owls are so unlike all other owls that they are classified in their own family. And so there are two families of owls. One has only one modern species classified in it. Vultures are not a biological group. It has long been recognized that there are profound differences between the Old World vultures, which are now classified with hawks and eagles, unlike the New World vultures. For a while, New World vultures were thought to be more closely related to storks than other birds of prey. That some early molecular sequencing suggested that, but that is now no longer thought to be the case. New World vultures and the condors are classified in their own order, cathartiforms. Although there is an ongoing discussion as to whether that should actually be considered a suborder of the accipitriforms, which includes the hawks and eagles. Most authors at this point, I think, seem to classify cathartiforms as its own separate order of New World vultures, condors, and some extinct forms like the giant teratorns, whose wingspan in North America could reach 18 feet or even over 25 feet in South America. All of the remaining raptors in this image are more closely related to each other, being classified in the same bird order of accipitriforms. Within this bird order, there are two families which contain only one modern species each. One contains the long-legged secretary bird, and this is interesting since some fossil raptors had longer legs, and the osprey. So while the osprey was called a fishing eagle and was sometimes connected to the other eagles, it is in a family all by itself. All of the remaining birds here are not only in the same bird order, accipitriforms, but also in the same bird family, Accipitridae. That being said, the relationships might not be what you would expect. All Old World vultures are not closely related. In fact, they belong to two different subfamilies, and one of the subfamilies is most closely related to a group of eagles, the serpent eagles. The eagles do not form a biological group. So golden eagles are not particularly closely related to bald eagles. Bald eagles instead are classified in the same subfamily as red-tailed hawks. But goshawks are in a different subfamily, so hawks are also not a biological group. So unfortunately, as our scientific understanding of the natural world improves, the new understanding may not match the categories and the words in common usage which we have come to expect. So raptor, in a scientific sense, doesn't really mean much, nor does eagle, or hawk, or vulture. These are groupings of birds which aren't all that closely related. Even the idea of birds of prey, lots of birds eat animals, although sometimes these are fish or invertebrates or nestling birds, and some of the birds which do this we don't classify as raptors. I remember when I was living in South America and trying to classify birds, some of the birds which were called either an eagle or a hawk in English, in Spanish would be called the opposite. And so some of the hawks for an English speaker would actually be an eagle for a Spanish speaker. So it's complicated, but science is like that. If we're going to correctly understand the natural world, we have to continually challenge what we think we know, and sometimes we're forced to adopt a new, more complete understanding, even if it's frustrating.